Hello there, Mr. Sutton bringing you these BC Calculus Quiz 5 review solutions on advanced integration techniques. For this problem, we're trying to integrate this expression. Now, this is a good candidate for partial fractions. The reason we're going to use partial fractions on this, well, we've got a fraction that we can't simplify, and we also can't use substitution. If you take the derivative of this denominator, 2x minus 8 is not going to help you out with canceling out this 6x. So really, partial fractions is kind of our last resort. We're going to try to split this denominator into factors and split up the whole fraction into two different fractions, which we can then hopefully use our ln antiderivative on. So first step, factoring. We have two numbers that multiply to 15 and add up to negative 8. That would be negative 3 and negative 5. And now I'm going to split this up into a over x minus 3 plus b over x minus 5. Next, I'm going to multiply both sides by this x minus 3 times x minus 5. That'll get rid of all the fractions. So over on the left side, I've just got 6x. On the right side, the x minus 3's are going to cancel, leaving me with a times x minus 5. And then over for this expression, the x minus 5's cancel, leaving me with b times x minus 3. After that, I'm going to pick values of x that allow me to cancel out one of these terms on the right side, allowing me to solve for the constant in the other term. So for example, if I want to solve for the value of a, I'm going to pick x to be 3, because that's going to cancel out this b term. So if I let x equal 3, on the left side I've got 6 times 3, so 18. On the right side, I've got a times 3 minus 5, so that's negative 2a. And again, this b term is going to cancel completely because we've just got b times 0. So if 18 equals negative 2a, that means a equals negative 9. Next, let's try and cancel out the a term so that I can solve for b. So for this, I'm going to pick x equaling 5, because that's going to give me 0 times a. So if x is 5, 6x is 30, and b times 5 minus 3 is going to be 2b. Dividing by 2, we've got b equals 15. So at this point, we're going to split up our integrand into these fractions that we mentioned before. So we've got, instead of writing all this inside now, we've got negative 9 over x minus 3 plus 15 over x minus 5. Now I'm just going to use my antiderivative rules here. So I've got, this is going to be negative 9 ln absolute value of x minus 3 plus 15 ln absolute value of x minus 5 plus c. For this problem, we're trying to integrate this product here. Now, we're going to use integration by parts on this, and the reason we know we have to use parts on this is honestly because nothing else is going to work. We can't multiply these together to get just one kind of expression that we can integrate. There's no way to merge these. There's no way to simplify it. There's no way to use substitution. We have an inner function, but its derivative is not going to cancel out the x over here. So in these situations, we try integration by parts. Now to do this, we have our integration by parts formula. Integral of u dv equals uv minus integral of v du. And we have to pick out u and dv in the beginning, and that'll help us get all the parts we need for the right side of the formula here. So when we're picking u, the acronym I usually follow is LATE. That's logarithms, algebraic, trigonometric, and exponential. That's the order of preference for picking the u value. In general, I want my u value to be something that I don't mind taking the derivative of, because I have a du over here that I'm going to need to find. And I want my dv to be something that I don't mind integrating, because this is going to need to turn into v. So taking a look at these, I have a choice between an algebraic and a trig for u. I'm going to let the algebraic be the u value. I would rather differentiate that than integrate that. Trigonometrics, they're not so bad to integrate. Cosine, for example, is just going to give us sine, which isn't horrible to have to integrate again. All right, so u is going to be 7x. dv then is going to be cosine of 2x dx. Note that the dx goes, wherever you have a d in one of these, you have a dx at the end in your actual expression. And now taking the derivative of u, du is going to be 7 dx. And then over here taking the antiderivative of dv, v, that is going to be, let's see, sine of 2x divided by 2, so 1/2 sine of 2x. Now to multiply these together, I'm going to follow the 7 here. If you make a little 7, that tells you kind of the order that things are going in as you plug them into this formula. So I have u times v. That's going to be 7/2 x times sine of 2x. And now I have to subtract the integral of v du, so minus the integral of, this is now going to be 7/2 sine of 2x dx. So these two expressions are kind of similar, except this one has an x, this one doesn't. For our next step, I'm just going to rewrite this first bit of stuff here. That's not going to change. But now I have to actually integrate this. So sine, the antiderivative of that is negative cosine. There's already a negative out here, so this is going to be a plus. And I'm going to have to divide by this inner tail now. So I'm going to end up with plus 7/4 cosine of 2x. And don't forget the plus c. For this problem, I want the integral from 1 to 8 of 3x f double prime of x, given this table of values for f double prime and some other derivatives and non-derivatives of f. So to get started on this, what technique should we use? Well, we're multiplying two things together, and we can't simplify them. We also can't use substitution. So we're going to have to go ahead then and use integration by parts. There's really no other option. And I'm going to use the definite integral version of that because I am taking a definite integral here. So I'm going to go ahead and write uv evaluated from a to b minus integral from a to b of v du. Let me pick out my u and my dv values now. Now normally for picking u I would use the acronym LATE. The problem here is that, I know that 3x is algebraic. I don't really know what f double prime counts as. So we have to kind of take a step back and think a little harder about how we really pick u and dv values. We want u to be something that we don't mind taking the derivative of. We want dv to be something that we don't mind taking the antiderivative of. So given a choice between these things, well, 3x, I can take the derivative of that. F double prime, I can't take the derivative of that. I can. F triple prime obviously is the derivative of f double prime. The trouble is this table doesn't have any information about f triple prime. Since we don't have any other information about the function f at all, we kind of have to just work with what's in this table. So I'm going to let my u value be 3x, and dv I'm going to let that be f double prime of x dx, because we've really got no other choice. F triple prime is a total dead end here. All right, derivative of 3x, that's going to be du equaling 3 dx. Antiderivative of f double prime, well, this is actually kind of nice because we have values for f prime, which is the antiderivative of f double prime. So for our v value, that's a good step in the right direction. We can at least take an antiderivative, and we're going to get something meaningful from doing it. Now it's time to put it all together in my formula. So for my uv evaluation box here, following my 7, I've got the top of the 7 here, the 3x times f prime of x. And again, we're going to plug in 1 and 8 into that eventually. Now I'm subtracting the integral from 1 to 8 of, now we've got f prime times 3, and with a dx there. And one more little step here before I actually plug anything in. I need to take the antiderivative of this function. So the antiderivative of 3f prime is just going to be 3f. So when the dust settles, inside my evaluation box, I've got 3x f prime of x. And then we're subtracting just 3f. And all of that's being evaluated from 1 to 8. So I'm going to plug 8 into all that stuff. So there should be an 8 there. There we go. 3 times 8, f prime 8, minus 3 times f of 8. And now we're going to plug 1 into all that stuff. So 3 times 1 times f prime of 1 minus 3 times f of 1. Going through now individually here, we've got 24 times what's f prime of 8? Well, that's going to be negative 3. Minus 3 times f of 8, which is 3 times 9. And then over here, we've got 3 times 1, which is just 3, times f prime of 1. Well, what's f prime of 1? That's 4. So 3 times 4. And then we have minus 3 times f of 1. Well, f of 1 is just negative 2, so negative 3 times negative 2 there. Going through now and simplifying a little bit, Free response, you could just leave it in this form here, but if you want to keep going, we've got negative 72 minus 27, so that's going to be negative 99. And over here, we're subtracting, let's see here, we've got 12 plus 6, so we're subtracting 18 over there. Negative 99 minus 18, that's going to be negative 117. For this problem, I want the integral from 2 to infinity of this expression. Since I have an infinity in one of my limits of integration, this is an improper integral, so I need to immediately turn this into a limit with a limit outside here. I'm going to make this the limit as b approaches infinity of integral from 2 to b times all this stuff. And again, the reason that we need to do this is right here, if you have infinity, you're essentially saying, hey, I'm going to plug infinity in. Here you're just saying, I'm not going to plug infinity in. I know I can't get there. I'm just going to approach it. So let's go ahead now and take the antiderivative, and then at the very end, we'll apply this limit. So for this one, I see I have an inner function here of 8x to the 5th, and its derivative, something with an x to the 4th, is also hanging out. So I'm going to try substitution in this situation. I'm going to let my u value equal 8x to the 5th. Then du is going to be 40x to the 4th dx. And then dx, because I'm going to have to substitute back in for that, is going to be du over 40x squared, or 40x to the 4th. Now I also have to pick out my u values. Right now the limits of integration are x values. I need to change those to u values if I'm changing this to a du and a u. So if x equals 2, then u is going to be 8 times 2 to the 5th. Well, 2 to the 5th, that's essentially 32. 8 times 32, that's going to be 256. And now if x equals b, well, that's a little bit easier. That's just 8 times b to the 5th. Plugging it all in, I've got the limit as b approaches infinity of the integral from, now we've got 256 for the lower limit instead of 2. And instead of b, we have 8b to the 5th. Now we've got in here 4x to the 4th times e to the u, which was kind of the whole point of making this substitution. And we also have a du over 40x to the 4th instead of the dx. Well, these x to the 4ths cancel. 4 over 40 we could reduce to 1/10 if we wanted. Then we have an e to the u, and we have a du there as well. Don't forget your differential. And now the antiderivative of 1/10 e to the u is just 1/10 e to the u, evaluated from 256 to 8b to the 5th. Notice that my limit is still here because I haven't actually tried to apply b approaching infinity anywhere yet. So until you actually apply that, this limit sticks around. All right, I'm going to take this 1/10 out, kind of factor it out of there, and inside of parentheses next to it, I'm going to have e to the 8b to the 5th minus e to the 256. And let's see here. If I now allow b to approach infinity, what's going to happen to this first term? Well, that's just going to make this exponent infinitely large. E to something infinitely large is infinity, minus some constant is just going to still be infinity. So this is infinity, but we can't really accept infinity as a final answer here. This just means that there's no limit, and since the limit does not exist, that means this integral diverges and has no value. For this problem, I want the integral from -1 to 1 of 1 over x to the 1/3. So before you take the reverse power rule on this thing and plug in 1 and -1, the thing to keep in mind is that we have a discontinuity at 0, because then you're essentially doing 1 over 0. And this is a big problem because 0 is inside this interval of integration here, between -1 and 1. So we're going to treat this as an improper integral, again, because of that discontinuity at 0. So to deal with this specifically, I'm going to have to split my integral up because the 0 is not one of the endpoints. It falls in between the endpoints. So I'm going to have two integrals, one that covers everything from -1 to 0, and then one that covers everything from 0 to 1. First one, I'm going to have the limit, and this is how I make this legal, make it proper, limit as b approaches 0 from the left of integral from -1 to b. So I'm going from negative 1 to b, so I have to approach 0 from the left side. And I'm just going to make this a negative exponent so that I can deal with it easier when I take the antiderivative. Next, I have to deal with everything from 0 to 1. So for that, I'm going to have the limit as a approaches 0 from the right side now. So, and then we have the integral from a to 1 of x to the negative 1/3 dx. For the antiderivatives on these, this bumps up to a 2/3 power multiplied by the reciprocal of 3/2. So we have limit as b approaches 0 from the left of 3/2 x to the 2/3 from negative 1 to b. Over here, everything is going to be the same in terms of the antiderivative, but I've got the limit as a approaches 0 from the right, and we're doing this antiderivative from a to 1. Now plugging things in, I'm going to yank this 3/2 out so I don't have to deal with it later. And when I'm doing the 2/3 power, I'm cube rooting and squaring. So this is going to be the cube root of b squared inside minus the cube root of negative 1 squared. Over here, take out a 3/2. Still got that limit there. I've got the cube root of, 1, and then square that, minus the cube root of a squared. Let's evaluate all this. So over here, as b approaches 0, that means this term is going to 0. So it's really just this one I'm worried about. Cube root of negative 1 is just negative 1. Squaring that gives me positive 1, but then we're subtracting again, so that's negative 1. And don't forget the 3/2 out in front. So when the dust settles, that whole thing comes out to negative 3/2. Over here, something pretty similar happens. Cube root of 1 is 1. Square that, you have 1. As a approaches 0, this second term goes to 0. So you just have 3/2 times 1 that you're adding over there. Well, that's a pretty easy addition. That goes to 0. So 0 is our answer for this one.